Okay, well, today I'm going to look at, we're going to start looking at classes and object-oriented programming. Um, Today's content comes straight from the textbook. A lot of times I kind of put my own spin on things and expand, but I feel like the textbook does a really good job. So today's notes and lecture come straight from the textbook here. Okay. And what we're going to do is we are going to create classes, okay? This is basically a user-defined type, okay? So Python has its own types like lists and dictionaries and things like that. And when you work with a list, it comes with its own attributes, right? So you can ask for own attributes and methods. So for example, when we imported NumPy and we created an ND array, that was basically a new type, and it comes with its attributes like the shape and and dimensions and things. Um, this time, we're going to create our own because this can be useful. So just kind of as an example, what we're going to do is we're going to create a class, a type called point, okay? And it's going to represent a point in two-dimensional space, much like an XY Cartesian coordinate um, thing. And so, there's a few ways we can do this. And one is you can just store the values separately. You can create a variable for X and a variable for Y. Another is you can create a tuple, okay? And the one we're going to look at today is we're going to create a new type to represent points as objects. This is by far the most complicated of the methods. Probably if I weren't trying to do anything unique, I would just use a list or a tuple here. Okay, a tuple probably makes sense, unless I need it to be something that can be changed. But here we're going to use we're going to create a type. Okay, and when we do this, we're creating a class of objects. Okay, and you define a keyword class with the keyword class, and then the convention is to capitalize the class name. So when we define a class point, the convention is to capitalize it with a capital P. This is not like a rule in terms of Python will throw an error if you don't do this, but it's convention. So if you want people to not criticize your code, this is what we do. Okay, so this is it. We just say class point, okay, and that defines a new class, okay. And right now inside our class, we are not defining anything, okay. And that's how it's going to be for today's lecture. Today's lecture, we are only going to define classes just by using the keyword class and the name of the class name point. In Friday's lecture, we will start defining the insides of the class. But even with just this structure right here, you can we can start discussing the ideas behind classes and objects and instances of objects. Okay, so this is all you need. All you have to do is you say class, you give it the name. Also, convention is you have a doc string to kind of indicate what the class is for. And that's it. That's it. You don't even need to have anything on the inside here. Okay, so here we have this, and this defines a new class point. Okay, again on Friday we'll talk about defining stuff that goes into it, but right now we'll just leave it like this. Okay, and so what this does is it creates a class object of type point. Okay, and if you say, well, okay, well, what is point? Okay, this is a new class. Okay, it's a class that exists inside main. Okay, it's defined at the top level, so its full name is technically main under main point. Okay. Okay. And when you do this, the class object is basically like a factory for creating instances of this particular class. So to create a instance of the point class, you call point as if it were a function. Okay, so we've defined this thing called a point, and we say, okay, I want a version of this, and we're gonna call it. So basically, I'm going to create a blank, an object called blank, and it's going to be an instance of the point object. Okay, so the point object, point class, to call it, you call it kind of like a function, right? So you call point as if it were a function, and what this does is it creates an instance, and we're going to call that instance blank. Okay, so it says blank is an under main point. Okay, so this is an instance of point that exists in under main, and it gives us a hex address in memory. Okay, and this is to indicate that this is an object that exists in a certain location in memory. So this is an instance of the point object. Okay, which is different from the point class itself, which is a class. Okay, this is basically saying it's a point object, instance of point located here. All right, and so so the return value of our call to point is as a reference to a point object which we assigned to the name blank. And when you print the instance, Python tells you that what class it belongs to and where it's stored in memory. And right now, point is totally blank. There's nothing in it. Okay, so to kind of make it useful, we're going to give it some attributes, right? And so what we can do is we can assign values using dot notation to create attributes. Okay, so we created the object blank, okay, which is an instance of the point object. Okay, and here we're going to just give it a new attribute. We're going to give it an attribute called x, and so we do blank.x, and this is going to equal the float value 3.0. Blank.y is going to equal the we're going to assign the value 4.0 to the attribute .y in blank. Okay, and that's it. All right, you just assign these. So these were not part of the point definition. It's just, we're just going to say, hey, we're going to give you some attributes. Okay, and you know, this dot notation, kind of like if you have called the math module and load the math module, you can get the value pi, which exists under math.pi. It's kind of like that, but here we're assigning the values to named elements in the object. Okay, and so these elements, these are called attributes. Right, and so you can retrieve them later. You can say, well, what's, now that we've assigned 4 to blank.y, we can ask later, what is blank.y? And it tells us it's 4.0. Okay, and then you can also take this, like blank.x, and assign it to another object called x. Okay, and then we say, well, what is x? X is 3.0. Okay, and this x and this x have nothing to do with each other. It's just a coincidence that blank.x, the attribute name is x, and we assigned it to a variable named x. But the attribute names are inside this class. They're inside this class object. Okay, and so this x and this x, those are the names are unrelated. Okay. So yeah, there's no conflict between naming a variable x and having an attribute x inside the class. The attribute inside the class is completely separate, right? And you can then continue using this dot notation as part of any expression, right? So here, remember the format operator. Okay, so here I've got a string %g%g, which takes this, right? So if you change the value of blank.x, does it change the value of x? Yes. So they reference each other. So let me just kind of show you here. So I'm going to there's this. Okay. All right. So if I ask, so right now x is 3.0, and then if I change, I'm going to change this to 5.0. Okay. And then, oh wait, is that right? Sorry, I'm confusing myself here. Okay, no, I'm sorry, I'm mistaken. They are, I guess we're, when you, good question. If you change the value of blank.x, it does not change the value of x itself. I'm sorry. I thought x was a reference, but it's not. It's not. Okay, it's a good good question, and the answer is it does not. They are different. So maybe I'll include that. Okay, so let me put that in here. Okay, so add that to our notes. Okay. All right, so here we have, we're going to use the format operator. And so I've got this string here that says %g, comma %g. And so, and I'm going to pass it a tuple with the values blank.x and blank.y. Okay, and so this is going to format this to print. Okay, kind of as abbreviated float values, and so this will appear as the string 3, 4. Okay, or parentheses 3, space 4, comma. Okay, and so what we can then do is we can then create a function which we're going to call print_point. Okay, and we'll see a more efficient way of, you know, kind of making prints and stuff like that. But we'll have we're going to create a function called print_point. Okay, and basically this is going to return, it's going to print out the result of this thing. So notice that when I say print the point, okay, the argument that I pass is going to be p. Okay, and so here if I call print point on blank, okay, it prints out 3, 4. When blank goes into the argument here, this p is basically an alias for the object blank, and therefore when I call p.x, it's equivalent to calling blank.x, and p.y is equivalent to calling blank.y. Right? So so here we're passing the object here. Now obviously if I call print point on something that does not have this attribute .x, I'm going to get an error, right? I'm going to get an attribute error, and it's going to say attribute x does not exist for, you know, object blank or something. Okay, so that's what we've got here. Okay, so here we're going to define a class to represent a rectangle, right? So how can we design a class to represent a rectangle, right? And we have a couple options. One is we could specify one corner of the rectangle or the center or whatever it is, okay? And then specify the width and the height, okay? And or you could specify 2 opposite corners. There's several ways to define a rectangle in you know, its location on some kind of 2-dimensional plane. And so I'm going to just follow the book's example, which they choose to go with the first option, and they're going to kind of define one of the corners, and I think they choose the lower left, and they're going to put in the width and the height. Okay. So the class, again, to do this, we just write class rectangle. We include a doc string, so somebody who has questions about what a rectangle is can see this. Okay. So with the doc string, you can ask for something like help. Help on point, okay, and it has the doc string that we include, okay, and then it includes other stuff, but basically this is the thing here. All right, so we've got class rectangle. It's going to represent a rectangle, attributes width, height, and corner. All right, and the width and height will be numbers, and to represent the corner, we're going to use the point object that we've point class that we've used earlier. Right? Uh-oh, I did something wrong here in the formatting of my. I guess this will have to go on its own slide. Okay, so here we're going to just put in the width and the height to be, so I create an instance of rectangle, okay, and we're going to call that box. The instance of rectangle is going to be called box. I do box.width is 100, box.height is 200, okay, and then for the corner attribute, we're going to create an instance of a point, okay, so we're going to have box.corner is a point object, and then we're going to assign the corner to be at the origin, and so we're going to say box.corner.x is 0 and box.corner.y is 0, okay? Okay, and so what we can do is we can return instances of classes from a function, right? So we can create a function that says find the center of a rectangle, right? So we're going to pass it a rectangle object, and then what it's going to do is it's going to return an instance of a point object, okay? And that point object is going to contain the coordinates of the center of the rectangle, right? So this is what a function might look like. So we create a function called find center, and the argument that it's going to accept is going to be a rectangle object. It's going to be an instance of a rectangle, okay? And inside the thing, we create a new instance of P, the point, okay, which is a point class object. And then we're going to assign attributes p.x and p.y, okay? And then the value for px is going to be, we're going to take the rectangle, we're going to say look at the corner attribute x, and then we're going to add half of the rectangle width, so we're going to do rectangle.width divided by 2, and then for the center it's going to be the corner y corner, and then we're going to add half of the rectangle, half of the height for 2. Okay, so again, we're assuming the corner is the lower left corner, and then we're going to go halfway across the width and halfway up the height. Okay, and again, so if the rectangle object you pass, right, so this will work for, right, we've defined box here, okay, and box has these attributes. It's got corner, corner.x, and it's got width, and it's got height, okay, and of course, if the rectangle object you pass, like if we pass box to this, it'll work, but if the box, if we give it an object that doesn't have these attributes, then it's going to cause an error, right? So here we can say, all right, find the center of box, okay? And then if we try to ask, well, what is center? It's going to tell us what? It's going to Python's going to say it's a class point at here, okay? And so you might have seen something like this, where you know, if you run some kind of function like a zip, and it takes two lists and you're trying to interleave them together using the zip function, and you just say, well, what is zip? It's going to come back as something like you have a zip object, right? And that's rarely helpful. And so a lot of times these object-oriented things will just come back and say, yep, you've got an object of that class. And what you need is you need a method to some kind of function that interacts with that object type and produces what you want, right? And so lucky for us, or not lucky for us, but what we've done is we've created a function called print point that takes the point object, in this case center, and it, you know, it prints it out in a form that that we can read as humans, right? Otherwise, if you just say, well, what is center? It's not gonna list off all of the attributes that are inside. Okay, so this is what we have. We got print point, and then it lists off and says, yep, the center is at 5100. Okay, so objects are mutable. Okay, so like lists and things like that, you can modify things. So here, box width is currently 100. And what I can do is I can add 50 to the box width, and I can add 100 to the box height. And if I ask for what is box width, it's going to come back and say it's 150. Okay, and this is the same box object. I am not creating a copy of the box. I'm just modifying the attributes that are inside the box object. Okay, you can create a function that will modify the object itself. Okay. So here we create a function called growRectangle. It takes in a rectangle class object. We're going to give it two attributes, basically a delta width and a delta height, how much to change the width by, how much to change the height by. So we're going to say rectangle width plus equals, which is basically the same thing as something like this. Just you're going to say add d width to it and assign it back to rectangle width. Add d height, assign it back to height. Okay, so right now if we ask what is our box width and box height, we get back a tuple that says it's 150 and the height is 300. Okay, so I've got a tall box here. Okay, and then we're going to say grow the box by 5100, right? So we're gonna make it even taller and even wider, or wider and taller. Okay, and if I ask for the box width, it comes back, box width and box height, gives me back the tuple of 200 and 400 as well, right? So this is what we've done. Okay, so this function modifies the object that we've passed to it. Okay, all right, so there are advantages and disadvantages. There are pros and cons to everything pretty much. And so one thing is that it can get difficult to debug something like this, because when you run this function, it's modifying the object that you pass to it, and it's not doing it, it's not necessarily explicit. There's nothing, like if you run this, it doesn't print anything out to the screen. When you run this, we're not saying like take the function and assign it back to a new object. It's just taking the function and it's changing this object. And if you weren't aware of this behavior, if you're not familiar with what this function is doing, you might come later on and say, wait, why did my box width change to 200? When did this happen? And you're not going to find it in the code. There's not going to be anything that says box width is equal to 200. That statement doesn't exist. It happens inside this function, right? It happens inside here. And if you're not familiar, if you don't remember everything, each of these things, it could be difficult to track down, right? And especially, you know, the idea of having an alias here, right? So when I pass box into this function, right? So you might be saying, well, okay, where did I modify box, right? And you're going through and you're searching your code for instances of box. If you search box, you're not going to see box.width being modified here. What's being modified here is rectangle.width, okay, rectangle.width. And it's just that when you pass box as an argument here for rectangle, rectangle or rect becomes an alias for box. And therefore, when we modify rect width, it is changing box width. Okay, I don't know if this conundrum makes sense to you guys, but it's just the fact that if you're running something and you're saying, how did I end up with this number 200? It's not necessarily clear. Okay, I mean, it's very clear in this very simple instance, but you can imagine a bunch of code where it's you're trying to track it down, and so you do something like, I'm going to search for every time where I see the word box, and you don't see box being modified in here. It says rectangle's being modified, but because rectangle becomes an alias of box, when you pass it into for box, it changes there. So you have to just be aware of the behavior of all of these things. Okay. So anyway, that's one aspect. There's a few things you can do. One you can create copies of objects, and then therefore you're only working with copies rather than changing the objects themselves. There's a few things to talk about copy. Okay, so we're going to create a new object called P1. This is going to be an instance of point, and I'm just going to assign x and y. 3 to x and 4 to y for the attributes of P1, okay? All right, and so what I can do is we can import the copy module, okay? And we're gonna say, make a copy of P1, and we're gonna call that P2, okay? And so inside the copy module, there's a function called copy, okay? So you run copy.copy, and P1 is going to be a copy, P2 is going to be a copy of P1. Okay, so if we say, well, what is inside P1? And we ask to print that out, it comes back with the coordinates 3, 4. We say, well, what's inside P2? And it comes back 3, 4. But then we can ask, is P1 the same as P2? And it comes back false. Okay. What's going on here is that P1 and P2 have the same attribute values. Okay, they're both going to have x is 3 and y is 4, but they are not the same instance. Okay, so when you use equal on a when you use the kind of the check for equality here, what it's doing is it's checking to see, is it the same object? Okay, so this is running equals on an object. Class object is the same as running P1 is P2, and P1 is not P2. P1 and P2 are copies of each other. Okay, so they are not the same instance, and so if you just call what is P1, we see it's an instance of point located at this memory address. And what is P2? It's an instance of point located at this memory address. And if you look at kind of the last three digits of the memory address, you can see that they are objects located at different locations in memory. So they are different things. Okay. So when we bring up the idea of copies, we have to bring up the idea of shallow copies and deep copies. Okay, and what we have is I'm going to demonstrate this using the our object box. Okay, box is a instance of the rectangle class. Its width is 200 and height is, I don't know why I didn't print out the height. Okay, the width is 200 and the height is 400. I'm not sure why it didn't show here. I'll rerun my code. And the point, it's got a corner, okay, which is a point object located at this memory address. Okay, and the corner of x is 0, and the corner of y is also 0. Okay, something. All right, I don't know why it didn't print. Okay, but anyway, width is 200, height is 400. The corner of x is 0, and the corner of y attribute is 0. Okay, corner itself is a point object located at this memory location. Okay, I'm going to make a copy of box. So I'm going to call box2 as a copy of box. Okay, so we got copy.copy box, and that gives us box2. Okay, and we can say, well, is box2 the same as box1 or box? And it's going to say false. Okay, box2 is a different instance of rectangle than box. Even though we've created a copy, it's a different instance, much like P2 is different from P1. Okay, however, look at this. Box2.corner is box.corner. That comes back true. Okay, and what it has done is it has copied the reference. Okay, so if I say, well, what is the corner object at box2? It's an instance of point located at this location in memory. What about the corner object in box? It's also an instance of point located at the same memory address. They are pointing to the same point object. Okay, and so so the corner attribute is a point object, and both box and box2's corner refer to the same point object. When you use copy, it creates a copy of the object and the references, but doesn't actually create copies of the embedded objects. Okay, so what will happen is if I modify the x attribute of box.corner, so if I say box.corner x is 1, box.corner x becomes 1, but then box2's corner also is x. Okay, so now, so it's basically I have two boxes, and their corner is the same. And so when I move one, it's like they're linked together. And so so changing the x attribute of the corner here is also going to change the x attribute of the same corner, because they're pointing to the same corner object. Okay, so they're separate, but they share the same point object. So here the height objects are separate, because box and box2, those are copies, and so right now their heights are 400, but if I modify box's height to 200, box height becomes 200, but box2 height remains 400, because box2 is a copy, and so its attributes, which are direct values, those get copied. But within box, there's a reference to a point object. Only the reference gets copied, not the values themselves. Is that okay? All right, I hope so. Okay, if we want to copy the embedded objects, we have to make a deep copy. Okay, and so to do deep copy, you can call from the copy module. There's a function deep copy. Okay, and we'll call box3 is deep copy, and box3 is not the same as box. And if you check box3 corner, it's not the same as box.corner. Okay, so that's they're different objects. They're pointing to different things. Okay, so that's going to be deep copy. So deep copy doesn't copy the references, but creates actual copies of the embedded objects themselves. Okay. A lot of times we will want to write functions that interact with objects and classes. Okay, we're not yet talking about methods. Okay, methods will come later, but right now we're going to talk about functions that interact with objects and classes. And we've seen some of this stuff already. Okay, but let's say we're going to create a class called time. Okay, and it's going to show the hour, minute, and second. Okay, and so here I create an instance of time. Lowercase time is an instance of capital time. And I've got time.hours 11, time minute is 59, time second is 30. Okay, so 11, 59, and 30 seconds. And then we're going to print this. Okay, and then so %.2d will take an integer and print it as an integer with a leading 0. Okay, so if it has a if the number is like 2, .2d will insert a leading 0 and stuff like that. Okay, so this is just kind of something with the format operator. Okay, so we use the format operator passing in the tuple with t.hour, minute, and second. Okay, so t. So here we're going to pass the time object into here, and it pulls out the attributes hour, minute, second, and it prints out 11:59:30. Okay, so we've seen this a little bit already. Okay, but there's kind of an idea of pure functions and modifiers. They're both functions. Okay, but a pure function does not modify any of the objects that are passed to it. Okay, it takes arguments in, it does stuff, and it returns a new object. Okay, and it doesn't modify anything that's inside, and doesn't modify any of the objects. The only way it interacts with things is arguments get passed in and it returns a value. Okay, this is kind of how R works. Okay, it has no effect other than returning a value. Okay, and here we're gonna try to develop a function, a slightly complex function. It's not too complex, but just kind of the idea of having a slightly complex function. And the idea is you start with a simple version called, we're going to call it a prototype. And then as we discover deficiencies of the prototype, we incrementally add complexity to the program. Okay, so here we're going to say we want to make a function that's going to take 2 time objects and add them together, right? So if I have time 1, which is the hour, minute, second, and time 2, t2, and which has hour, minute, second, we can say, all right, let's create sum, which is going to be another time object. Okay, and we're going to take the hours and add them together, take the minutes, add them together, and take the seconds and add them together. Okay, and so this is, and then we're going to return the sum object, okay, which is an instance of time. So here we accept time objects as arguments, and then we return another time object called sum. Okay, and so so let's say we're going to start something at 9:45, and then, whoops, I messed this up again. We start something at say 9:45, and we're going to add an hour 35 to it. Okay, and so using our function as it is, 9:45 plus an hour 35, when we add those together, we get 1080. Okay, 1080 is not correct, right? It added the hours. It did exactly what we asked it to do, but what we needed to do is we needed to recognize that you can't have minutes over 60, you can't have seconds over 60, and things like that. So we need to take that and tack that on, you know, kind of carry things over. Okay, so we have to. So we're going to make our add time function more complicated. Okay, and so we're going to say we're going to do the same thing. Take the hours and combine them, take the minutes, combine them, take the seconds and combine them. Okay, and then we're going to say if the sum of seconds is greater than 60, subtract 60 and then add 1 to the minute. Okay, and if the sum of the minutes is over 60, subtract 60 and add 1 to the hour. Okay, so we can do that. And if I add the 2 times together, rather than getting 1080, I get 1120. Okay, and that seems like what we want. Okay, so what we want to do is it can be useful for a function to modify the object. Okay, And so this is going to be a modifier function. And so notice what here we're going to take a time and we're going to increment it. We're going to take an argument, which is the number of seconds, okay? And so we're going to take our time, and we're going to take time in seconds. We're going to increment it by seconds, by the number of seconds. And we're going to say if the time in seconds is greater than 60, subtract off 60 and add 1 to the minute. If the time is for the minute is greater than 60, subtract 60 from the minute and add 1 to the hour, okay? And notice the difference here is we're not returning. So back here we created a new instance of time and we returned the new object. Here we are not creating a new instance. We are taking the time object and we are modifying it directly, okay? And so here we can create a test time, and again, somehow look better. So here we'll create so here's our modifier function. We create a new time here, which is 9:45, and we say let's add 90 seconds to it, okay? And then it comes back with 9:46:30. 9:45 plus 90 seconds later is 9:46 and 30 seconds. That's correct, okay? If I try to add 185 seconds, though, the function does exactly what I tell it to do. I'm going to add 185 seconds to this time, 9:46:30. 185 is basically 3 minutes and 5 seconds. But what it does is it basically adds only 1 minute to the minute and adds 125 seconds to the seconds, okay? And that's because all I did was say, if it goes over 60, subtract 60 and add 1. And so, so this is not going to quite work if the number of seconds is much larger. Okay, is much larger than 60, so it breaks there. So, so in that case, it's not enough to carry. So when I rendered my slide, something must have happened. Okay, I'm going to just go directly from the notebook. Okay, when so in that case, it's not going to be enough to carry over once. What we have to do is we're going to have to, you know, one thing is we could keep running this, do a while loop until we make sure time.seconds is less than or equal to 60, okay? Or another is we can use modular division, right? So here we can take our increment function, which takes the time object, and we're going to take seconds. And if seconds is a huge number, what we can do is we can run modular division, okay? And we could take the number of seconds and divide by 60, and it's going to return basically the whole number part, okay, which will be the number of minutes, and then the remainder will be the number of seconds, okay? And then in case this number is huge, we can div mod the minutes by 60, and that will return the number of hours, the whole number of hours, and the remainder will be the number of minutes, okay? And now I can modify the seconds by adding the seconds, modify the minutes by adding the number of minutes, modify the hour by adding the number of hours. And then now we know that second, that whatever this is, okay, as long as time was kind of a valid time before, when I add this, we're not going to get a number, we're not adding a number greater than 60 here. So I can just do it, you know, if it's greater than 60, subtract off 60. If it's greater than, and add 1 to the minute. If the minute is greater than 60, subtract off 60 and add 1 to the hour. Okay, so that will work. And when I run it, indeed, it works. If I do 9:45 as my start time, test time, and then we're going to increment it by 185 seconds. Okay, then it comes back 3 minutes and 5 seconds later is 9:48 and 5 seconds. If I add 4,800 seconds, which is equal to an hour and 20 minutes, it correctly adds an hour and 20 minutes. Okay, so 20 minutes after 48 is going to give us 10:08, and then an hour there will take us to 11:08. Okay, so this seems to work. Okay, all right. And so just kind of a note is that Python allows us to write these modifier functions, which are useful. Okay, and modifiers are convenient, but as I mentioned, they can be more difficult to debug because it's not always clear when an object is being modified. All right, so that's just something you got to be careful of. R, on the other hand, if you're familiar with R programming, R only allows pure functions. You don't have really modifiers, okay, with the exception of R6 and reference class. And so if you're explicitly dealing with object-oriented programming in terms of reference classes, then you have modifiers. But in general, R is mostly a pure function type of language, okay? But Python allows for modifiers, which can be useful as far as coding things up quickly. All right. So what we did, the strategy that our textbook walked us through was kind of this notion of prototype and patch. You create a simple version of the function, and then as you test it with different test cases and run into errors, you say, oh, you know what, we've got to patch up that error, right? We've got to fix it up so that it behaves the way we need it to, okay? Another is you can do designed development, as in you take a step back and this is like nice, and you have like this kind of you're thinking hard about how we should approach the problem in the first place, right? And you can implement maybe a more elegant solution. Brandon asks, can you create your own classes in R? Yes, absolutely. You can create your own classes in R. It's something I cover in my 102A class, but that's not here right now. So yeah, if you take 102A, I'll cover classes in R. So I'm going to run out of time, but basically, if you have a deep understanding of the problem, you can probably take this designed development approach. You can just say, oh, you know what, let's approach this using, this elegant solution, right? So, there's different algorithms and stuff that you can write. You can say like, oh, you know what, let's create this kind of problem and let's use this recursive solution, or let's, and this kind of approach is nice, and usually, but to be honest, usually it's hard to have this because it requires a deeper understanding. And so, I'll let you read through this, but basically, one approach is to take a time object, convert it into integers, which is just going to be the number of seconds after a certain amount of after midnight. And then you create another function that converts the number of seconds back into a time object, okay? And then with that, once you have that, so here you can convert 9:45 into seconds, and you can convert this number of seconds back into the time 9:45. And then what you can do is then you can just say, well, let's convert everything to the number of seconds, if you want to add times together, you convert them to seconds, add those seconds together, and then take that total number of seconds and convert it back into a time. And if you think about that, you go, oh yeah, that's a pretty elegant approach. Okay, that's actually kind of how the date object in Python in most computers work today. Date objects are generally, if you look at a date object, it's generally stored as an integer, which is just the number of days that have passed since January 1, 1970. That's the epoch time. And or it might even just be the number of seconds, or for the time it will be the number of seconds since January 1st, 1970 midnight, the epoch time. And And basically all date objects are just, you deal with the integers and then you convert it back into dates after the fact. And that avoids all of this unnecessary stuff, because if you think about it, our calendar is really weird and irregular, and you've only learned it because we started drilling it into you since you were like 4 years old and stuff. But you know, like you have to know that February has 28 days. Sometimes it has 29 if the last, you know, if the year is divisible by 4, except when it's divisible, you know, except when it's divisible by 100. But yes, when it's divisible by 400, and you know, it's weird, right? So anyway, I've run way over my time, and so we'll end here. And I forgot to make an attendance quiz. I'm so bad. So I will, you know what, let's just do AA for the attendance quiz, A, and I will, give me a second, I will make that right now for this class 21. Okay, so we'll say attendance quiz. Don't take it right now. Let me do this. This will be okay. So hang on. Let me hide this for the time being. Okay, and then let me modify this. And but okay, so it will pop up in like 3 minutes here, and the answers will be A and A. Okay, so